Hello, Professor Sullivan. This is my video to accompany my paper on color blindness. This is my first time ever doing a recorded slideshow, and I'm a little nervous just because it's being recorded. So hopefully I'll be able to get my point across and not mess up too bad. So here we go. Go to the first slide. Color blindness, also known as color vision deficiency, is a condition where someone afflicted with it perceives color differently than those with normal vision. At times they can't see certain colors at all, and other times they are unable to see certain shades of that given color. Those with color blindness often aren't able to see my favorite color, which is mauve, which is sad. There are many types of color blindness, the most common type of color deficiency being the red-green type called dichromacy. It's most common in men, and about 1 in 12 men suffer from it, compared to only 1 in 200 women. Color blindness is actually way more common than I thought it was, which is sad, but I'm lucky enough to not have it. Red-green, though, isn't the only type of color blindness. There are others, including yellow-blue, which is called achromatopsia. More types include protanopia, blindness to red, deuteranopia, blindness to green, and tritanopia, blindness to blue. But there's more, just way more even than that. The reason for the 3 main colors involved, being red, green, and blue, is because in our eyes, located in the retina, are what's called rods and cones, which are photoreceptors. The retina is the light-sensitive area of the eye that sends visual information to the brain, and the rods and cones are how we see and perceive light and color. The red, green, and the blues mix together like mixing paint and make combinations, making all the different shades and hues of every different color you can imagine. But people who are colorblind are unable to see these colors, whether that be pinks, or yellows, or shades of green, or purples. Some kind of color they just can't see because one of the photoreceptors either isn't there, or just works not so good. Here in this picture, what colors do you see the kids wearing? I see pink, green, and blue. But those with color vision deficiency would have trouble seeing 1 or more of these colors. To someone suffering from color blindness, 1 or more of these main 3 colors aren't visible, or they perceive them as very dull. Therefore, they cannot see the shade that is associated with that weakened or absent color. So, for instance, the pink jacket they may see as white. They may say that the green jacket is red, depending on what kind of color deficiency they have. Here's an example of what color blindness looks like to someone with normal vision. On the left, we see children with normal vision, and on the right, we see what a colorblind person may see. Very dull, much less green, and kind of focused more on blues and reds. Here we have another example of what color blindness can look like. Here we have normal vision showing pink, purple, and blue pens. Then on this right-hand picture, there's what seems to be some kind of gray and 2 different shades of blue. So because they can't see the red in the purple, they see it as a dark blue. And because they can't see the red and the pink, they just see the white and the pink. And even the blue is a different shade of blue, which I find fascinating. The center photo is the color test. It's what they do to determine if someone has color blindness or not. Can you see the numbers in each circle? If you can, then chances are you have normal vision. If you can't, well, then you might have a color blindness. The numbers are 8, 6, 29, 3, 15, 74, 57, 5, and 42, which may just be the answer to everything. So if you can see the rainbow, you're definitely lucky, because otherwise you'd have to label everything. This is blue, this is red, this is green. So if you can see the colors, enjoy it. So that's what colorblindness is.